Welcome to Easy Math TV. This is part 2 of our introduction to the student t distribution, and it's also our introduction to inferential statistics, where we are making inferences about a population mean in this case. So in our first video, we saw how to create this chart here, and we also used it and compared it to values that are normal. So we basically compared the student t distribution with the normal distribution and saw that there were some key differences between the two. And one of them is that when you're working with the student t distribution, we are finding that that our margins of error are going to be wider. So we're going to need to expand our margin of error if we're going to if we want our probability to be a certain amount. So like if we want to hit a probability level of 95%, then we will we're going to see that there's a wider interval of values that are within 95%. So anyway, that's what we talked about in the first video. But in this video, we're going to answer some questions that are strictly based on the student t distribution. And if you recall, we talked about the fact that probability values are determined by the degrees of freedom, which is also determined by the sample size. So basically, we're going to need to specify the sample size in every one of these problems in order to answer the questions. Okay, so we're going to use this chart that we see here as just a lookup table, basically, for the value that we're interested in. And if we read the first question, it says, if the sample size is 18, what is the probability, so capital P is probability of, parenthesis of, t being less than or equal to 2.5. So when we see that inequality, t less than or equal to 2.5, we should immediately think, okay, that is the cumulative probability. Okay, that is the cumulative probability. So, hang on a second. I meant to color in the text there. So the cumulative probability when the number, the t value is 2.5. So basically over here, we're going to be looking at row 15. But the first thing we need to do is correct our sample size. Make sure that we have the correct sample size in our spreadsheet. So under sample size, I'm going to make that an 18. And now we can look at row 15. Across from the number 2.5, we have a cumulative probability of 0.9885. So our answer to the question is 0.9885. Okay, that's the probability of a t value being less than or equal to 2.5 if the sample size is 18. And it wouldn't matter if that's a less than or a less than or equal to. Question 2, for degrees of freedom equals 7. So now we have degrees of freedom is specified, and that's one less than the sample size. So we're going to go over here and we're going to correct the sample size to be 8 because that's one more than the degrees of freedom, which is 7. And now it's asking for the probability of a t-score being between -3 and +3. So we need to recognize that this is a probability between two values. So I'm going to go ahead, since we have the sample size correct, we fixed that. So now we need to go and put the lower value as -3 and the upper value is +3. And they don't have to be the same numbers. They don't have to be opposite in sign from each other. They could be slightly different. You just need to make sure that in D4 you have the lower one, and in E4 you have the upper one. So I'm making sure that I have all my information correct. So then all we're going to do is look for the answer to the question in cell E6, because we had already typed in the formula prior to this. This is the formula that we need for probabilities of t-values in between two numbers. So I don't have to touch that at all. I just wanted to show it to you that it's there. So we're just going to read that number. And so the answer is 0.9801. Question 3 says, what is the probability of t being between -3 and +3 if the degrees of freedom is 38? So we're changing the degrees of freedom now. Instead of 7, it looks like we're going to have a larger sample, okay? Instead of a sample size of 8, we're going to have a sample size of 39, because that has to be one more than the degrees of freedom. Notice sample size is one more than what you see in E2. So it's the sample size that we can type in. The value in E2 gets calculated based on our sample size. So our lower and upper values are the same, so we don't have to touch those. So this time the probability of a t-score being between -3 and +3 is a lot higher. And so that means, like, we can be more confident with our results. And it makes sense because when you increase the sample size, you're also increasing the probability within the same interval of values. So 0.9953 is our answer to that question. So now question 4 is kind of turning things upside down. It's asking for the sample size. So what sample size is actually needed if we want the probability of a t-score being between -2 and +2? So now we're even shrinking the interval. The interval is shrinking down to between -2 and +2, and we want that probability to be equal to 0.95. So I'm going to go ahead and change my lower and upper numbers. So this is a -2 in the lower, and the upper is +2. And as you can see, right now the probability is 0.9473. If you want the probability to increase, you have to increase the sample size. So right now it's 39. Let's see what would happen if we put a 45 in there. And we're going to keep bumping it up by 5 until we get really, and I mean really close to 0.95. And right now it's not. So, I mean, that may look close to you, but it's not like 0.9, it's not 0.0001 away. So if we increase from 45 to 50, notice what happens there. It's still not 0.95. So we're going to keep messing with it until we get something extremely close. So now that I have a 0.9499, so the digits right after the 0.94 are both 9s. So we know that we're really close now. And you could bump this up to a 65 just to see what happens. But that actually goes above what we're looking for. It goes a little bit above. So we know that our answer is probably going to be somewhere in between there. So let's go back to 60. And how about if we just go up by 1 this time? So what happens if I just make that a 61? Again, you can experiment with different sample sizes as much as you want to until you reach that value that we're looking for. And notice that when the sample size is 61, we have the probability of t being between -2 and +2 is exactly 0.95. I mean, if we expanded, we could go here and we could go to more decimal places, and Notice it's not exactly, precisely 0.95. But since we're talking about out to 4 decimal places here, that's pretty standard. That's reasonable. So if you can get to that 0.9500 within 4 decimal places, then you are fine. So the answer to this is that we need a sample size of n equals 61. Okay? We need a sample size of n equals 61. If we want the probability of a t-score being between -2 and +2 of 0.95, you know? Um, and, that's a good, it's a good kind of question to answer and ask, because it does help you to understand, you know, um, just how careful you need to be, and what size of a sample do you really need to get a decent estimate of your population mean. Okay. Um, so we're going to, right after this one, there's going to be a series of videos on confidence intervals. We're going to start with a proportion, and then we're going to do confidence intervals on a mean, and basically with and without data, like given whether you have the data in front of you or whether you just have summary statistics. So that's what's coming next. Like, subscribe, comment down below. If you think that these videos are helpful to you, please share them with other people. And, other people who are taking stats might find them handy and useful. So anyway, I'll see you in the next video.